All right, boys and girls, this is a review of Chapter 9.4. Just want to remind you guys that we know that this is a quadratic, and more specifically, it's in this form, ax squared plus bx plus c, because I know that there's a 7x squared is the a, 22 is the b, and positive 3 is the c. When we have equations like this, it does equal 0, and then next we want to make sure we don't have a common factor, and there's nothing that goes into 7, 22, and 3. So we learned in class to multiply the a and the c, and we get 21. And we're looking for the factors of 21 that add to 3. All right, so there's a couple, that factors of 21, but that add to 22. And the two factors of 21 would be 21 and 1, because they multiply to 21, but add to 22. So then I'm going to write it over as ax squared, the original ax squared, plus mx, which is 21x. The n is the 1, so plus 1x, plus c, which is the 3. And I'm going to set it equal to 0. Next, we have a 4-term polynomial, so we're going to group them and take out the greatest common factor. Here, the greatest common factor is 7x, because you have a 7 and 21, and they each have an x. And when I divide each of these by that, you're left with x plus 3. Now, you'll notice in here it already has an x plus 3, so we can assume that we're just going to have a 1 on the outside. Because you're taking out a 1, it won't change what's on the inside. And we're going to still have it equal to 0. Last, now that we have the same thing written inside the parentheses, we can use the distributive property and know that we could write it once as a binomial times the other stuff on the outside, which will form a binomial. 7x and a positive 1 would be plus 1, which both equals 0. Now that we have two binomials or a multiplication problem that equals 0, we can use our zero product property and set both equal to 0. And then solve. I subtract 3 on both sides, and I'm left with x equals negative 3, which is one of my answers of my quadratic. And the x could also be, if I subtract 1, I get 7x equals negative 1. I divide both sides by 7. And I'm left with x equals negative 1/7. And those are my two answers for x, and I'd write them in a solution set. Next problem. Very similar to this. You know, you have to notice in these problems that you have a quadratic. I see that I have an a squared, so we're going to have a quadratic equation. But here's the deal. I got all this stuff on the other side of the equation, so we're just going to use what we learned in the beginning of the year. We're going to bring everything over. So I'm going to subtract 4 on both sides, which leaves me with this groups together and becomes a negative 9. And then I'm also going to add 3a to both sides. And these things are going to add together and become a negative 6. So I'm left with negative 6a minus 9. I have my 8a squared. And now it equals 0, because I need my quadratic to equal 0 before I factor. Now, they don't have a greatest common factor, because I know that the 9 and the 6 do. But the 8 doesn't share that common factor. So we're going to do what we've done. We notice that it's in the form a trinomial ax squared plus bx plus c. So I'm going to multiply my negative 9 and my 8. And I'm ending with negative 72. So I'm going to look for my m and my n that get me negative 72. So what things get me negative 72? All right, well, we know negative 9, positive 8. Negative 8, positive 9. And do either of those add to our middle term, which is negative 6? No. So now we got to think a little harder now. What other things get me negative 72? So I could do the prime factorization of 72 and bring it all the way down to its prime factors and know that different combinations of those numbers are going to get me 72. So 3 times 3 times 2 is 18 times 4 will get me 72. Does that, and if one of them is negative, will that add to negative 6? No. Well, then how about 2 times 2 times 2 times 3, which is 6 times 3. Oh, that's the same one. So how about 3 times 2 times 2 times 2? So 2 times 2 is 4, times 2 is 8, times 3 is 24, and 3. Does that add to negative 6? Okay?
Negative 12 and 6.
But if we kept going, we would end up with negative 12, positive 6. And that's something that adds to negative 6, but multiplies to negative 72. So we're going to break down into what we did before, ax squared. And then I'm going to use my mx, which is negative 12x. Now, I changed them to, actually, it's a. And then we have positive 6a. And then our original c equals 0. Now we are going to group them like before. And the greatest common factor there is going to be 4a. And I'm left with 2a minus 3. Here, the greatest common factor is 3. And I'm left with 2a minus 3, which equals 0. Now I could write them as my two binomials, 2a minus 3 times 4a plus 3 equals 0. And at this point, I'm not going to go ahead and solve, but you would set this equal to 0 and solve, and set this equal to 0 and solve.